Okay, so we did set up our determinant. So hopefully this is clear how to get this A cross B. And then we're just going to apply what we learned. So basically we are using kind of right here, using this in here, right? But you can get it from determinant. So I'm covering the I had first, and I'm going to do fish to the right. I'm doing -3 meters times 7 newtons minus 2 meters times 5 newtons, and that's for the I had. Okay, so that's the first part. I meant to get rid of this. Okay, and the next part, so I'm trying to get this. I'm going to cover J hat, and I'm going to make the fish to the left. 2 times 0, that is going to be 0. And then minus 4 meters times 7 newtons, and that's what we have. And that's along the J hat direction. Okay, so let's get rid of that too. And the last part is for this last piece. Okay, for the K hat. So since you're getting K hat, you're going to cover that. And you're going to do fish to the right. 4 meters times 5 newtons minus minus 3 meters times 0, but this goes to 0 anyway. So then you're just gonna get a little bit simplified thing. So let's put these together now. Okay, get rid of these two. So what we have then is the first term here gives us -31 newtons meters. And the second term, since this goes to 0, is -28 newtons meters. And the last one is giving us, since this goes to 0, 20 newtons meters K hat. Okay, and this could have been really like a torque problem, because you could just say this is in meters, so this is your R vector, and this would be the force. And you're really doing A cross B in this case would be kind of R cross F. And what is R cross F? It is torque. Okay, so you kind of find out what torque is in each direction. So it's three-dimensional. So it's a mathematical method is the only practical way to compute this cross product, and the units work out to be Newton meters. And again, they could have said this is torque calculation, for example. Yeah, and what is torque calculation? So we saw that the magnitude of torque created by a force F was computed as F times R times sine theta. And F and R here are the magnitudes of the force and the moment arm, the distance from the pivot point to the force point, respectively, okay? And theta in this equation is also the angle between F and R. They are vectors, and we also noted that the direction of the torque vector is found from the right-hand rule, because we are using the cross product. Okay, so when you see a cross product, the first thing comes to your mind is the direction is related to right-hand rule. Okay, and now we see that this is exactly the result obtained from the vector cross product. So we can write torque is R cross F. So when I write it, I do write it this way. Instead of bold letters, I put the arrows on top. Okay, so I want you to really realize work term was similar, but it was F dot D. Okay, so it's like D dot F is the same thing. So it doesn't change, but you need to show what type of multiplication you have, and you can even call D to be R vector. So it would be like this is R dot F, this is R cross F, but they're not the same thing. This is scalar. It's because dot product is also known as scalar product, and cross product is also known as vector product. So the torque is a vector, work is a scalar, but they are both found by the multiplication of the displacement or R, the distance in magnitude, times the force. Okay, it's just a different type of multiplication will give you different type of quantities. Yeah, and we are going to talk about more of this, and I'm going to again start with the review for Monday after the exam. And but there are a couple clicker questions that you can work on now, just to, as it's fresh, kind of make sure you understand the math behind, so we can use this in the physics problems. And the clicker questions for today, for Friday, since we have the exam today, I'm giving an extra day, so it's going to be due Saturday nighttime. Okay, just check the email that I'm sending with this.